All right, guys, welcome to the second part of our review. Okay, we're starting off here talking about velocity. Velocity is very simple. Velocity is two things. It is speed. Whenever you hear the word velocity, you should think of speed. Velocity is how fast something is going, okay? But velocity is special because it's not just speed, it is also direction. So it's how fast something's going and whether it's positive, moving forwards, or negative, moving backwards, okay? Positive, negative, all right? Our equation here is velocity equals displacement divided by time. You'll often hear me say distance just because distance is shorter, but it's really displacement. And our units, super important. To measure distance and displacement, we use meters, M. To measure time, we use seconds, S. And to measure velocity, it's distance divided by time, so meters divided by seconds, or meters per second. Let's do a practice problem, okay? So for all these problems, we follow the same steps always. Number one, make a chart. So let's read this. A horse runs at 15 meters per second. We just saw meters per second measures velocity. Very good. This happens for 5 seconds. We know seconds measures time. And we're looking for how far did he run? How far is a distance? Question mark. Okay, make a chart, write down your equation. Velocity equals displacement or distance divided by time. Plug in our numbers. V is 15. Distance is, I don't know, and time equals 5. All right? Again, we want this distance by itself, so we circle it. Here we see division, so we do the opposite of division, which is multiply, and we always multiply by the number in the bottom, which is 5. Whatever you do to one side, you have to do to the other side. 5 divided by 5 is 1. Okay, and this gives me a distance equal to 15 times 5, which gives me a D is equal to 75. It's a distance. We always measure distance in meters. There you go. Groovy? Groovy. Let's do number 2. First step, make a chart. A plane is traveling 200 meters per second. Meters per second is velocity. How long does it take to travel 1,000 meters? As we saw, meters equals distance. And it says, how long does it take? Well, how long is the time? We make our chart. Next step, write down the equation. Velocity equals distance over time. Plug in our numbers. V is 200. And that equals, here, let me do this over here actually. V is 200, and that equals my distance, which is 1,000, divided by time, which is I don't know. Okay? Plug the numbers in there. Next step, what are we trying to get by itself? We're trying to get time by itself, T. All right, we can't have T in the bottom of the fraction, so we got to get it out. Jailbreak. This is division. The opposite of division is multiplication. Always multiply by the bottom of the fraction. So we multiply that side by t, so we got to multiply this side by t. T divided by t is 1. And now I have t times 200 equals 1,000. Bring that down. Again, I want to get t by itself. This is multiplication, so I have to do the opposite, which is division. And whatever I do to this side of the equation, I have to do to this side of the equation. 200 divided by 200 is 1. And this gives me a time equal to 1,000 divided by 200. Time equals 5 seconds. Sorry, I kind of got a little all over the place. But I'm sure you guys follow. Right? Beautiful. Okay. All right. Moving forward. And again, remember, you can always go back If you go back to my velocity video, there's like 5 examples that you can watch on there. Okay? We're good? All right, let's move forward. Next, we need to talk about velocity graphs. Okay, so a velocity graph has time on the x-axis, always measured in seconds, and on the y-axis is always velocity, okay? Measured in meters per second. That's how we know it's a velocity graph. Velocity is on the y, time is on the x. So let's read this. Here, we see that our graph starts way down here, okay? Our graph is starting in -11, all right? Now this is a flat line, which means it's not moving up or down, okay? Which means it's constant, right? It's not changing, but it's below 0, which means this is a constant negative velocity. From here to here, excuse me, we see now we're going from -12 all the way back to 0. Because we're going from a big number back to 0, this is a decreasing velocity, and it's negative. So this is a decreasing negative velocity, right? We're going from -12, each one of these is 2, -12, -10, -8, so forth until we hit 0, where we stop. 0 meters per second is a stop, right? We're not moving. From there, this line, we're going from 0 meters per second up to 18 meters per second. That is an increasing velocity, and it's above 0, so it's positive. Again, we have a flat line at 18 meters per second. That line is not going up or down, so now this is a constant velocity, and it's above 0, so it's positive, as opposed to being below 0 and being negative. This one's moving forwards. These are moving backwards, all right? And then here, we have a line going from 18 meters per second back down to 0. So this is a decreasing velocity. It's positive because it's still above 0. And then here and here, our velocity is 0 meters per second. So we are not moving. We can look at another one of these. Again, I don't know if you can read this, but you will be able to read it in the notes. Positive means moving forwards. Negative means moving backwards, right? If the line moves away from 0, going in either of these directions, that is an increasing velocity. And if the line moves towards 0, right, it's slowing down. That is a decreasing velocity. So again, our line starts at 0, meaning we're not moving. 0 meters per second. Okay? Or meters per minute. This is measured in minutes. Foolish graph. I would have made it seconds. We start at 0. We go up to 60. This is an increasing positive velocity. It's positive. It's above 0. What's this? Exactly. This is a constant velocity, and it's above 0, so it's positive. This is going back to 0. It's going towards 0, meaning it is a decreasing positive velocity. Right here, what's happening when we hit 0? We're not moving. From here, we're going from 0 down to -40 meters per second. We're speeding up in the negative direction. This is an increasing negative velocity. It's moving away from 0, but it's negative, which means we're just moving backwards. Okay? Last but not least, this line is going back towards 0 from -40 back to 0, which means that this is, you guessed it, a decreasing negative velocity. Why is it decreasing? Because we're going back to 0. We're going back to a stopping point, and it's negative because it's below the 0 line. Here we're moving forwards. Here we're moving backwards. Here, we're not moving at all. All right. How to take the slope of a position graph and turn it into a velocity graph. I'm going to do this quickly. I'm not going to calculate the slopes. I'll say them out loud, but I'm not going to draw them. I'm just going to do this very simply, okay? This first line here, this is a distance graph. The slope of this line is straight, and it goes upwards, which means it's positive. If you wanted to calculate it, your rise would be 60, and your run would be 10. 60 divided by 10 is positive 6. So this right here, for the first 10 seconds, is a positive velocity, which means we draw a straight line because it's constant, right? It's a straight line here, and it's positive because it's going up. Positive slope, positive velocity. And again, this is technically positive 6. Okay. Meters per second. This is time in seconds. Oh, I can never not do it. Okay, this line right here is flat. Okay? That means the slope of this line is 0, right? Our position is not moving up or down. We're not going forwards or backwards. It's flat, which means that from 10 seconds to 15 seconds, okay? Here is 20, 30, 40, 50, 20, 30, 40, 50 seconds. Our slope here is 0, okay? This is 0. Our velocity is 0 because our position is not changing. Our next line goes from here all the way down to negative 40. This is a distance graph. Okay, so this is a lot easier. If the line goes up, we're moving forwards. If it's flat, we're stopped. And if it's going down, we're moving backwards. Okay? This one is all straight, which means it's a constant velocity. We go from 60 down to negative 40. That is negative 100. And from 15 to 40, that is 25. That gives us a slope of negative 4. So from 15 seconds to 40 seconds, our velocity is constantly at negative 4. Why? Because that is the slope of the line. The slope of this line is negative 4. And last but not least, we have a line that's moving up. Okay. This is a rise of 40. We go up 40 and over 15, which gives us roughly a slope of about 3. I actually think it's like 2.8. So from 40 to 55, our slope is 2.8. Okay, so again, looking at this, right? If the position graph, the distance graph, the meters, if the slope here is positive, it's a positive velocity, which means it's above 0. If the slope is flat, it's a 0 velocity, you're not moving. And if the line goes down, it's a negative velocity. That's how you turn this into this. Position graph into velocity graph. All right. Again, I have a whole video on velocity graphs. Go back and rewatch that if you want to see more examples. Okay. Last but not least, we need to calculate the area under the curve. This is that trick that I showed you guys. If you have a velocity graph, if you find the area under that graph, you find the distance or the displacement, if it's positive or negative. What you have to do is you have to take that graph, take the area between the line and 0, and cut it up into rectangles and triangles. The area of a rectangle is very simple. It is the base of the rectangle times the height of the rectangle. Base times height equals area, B times H. If you want to find the area of a triangle, well, look at this. A triangle is just a rectangle cut in half. So we do the area of the rectangle, base times height, divided by 2. Simple stuff, right? Like I say, this is like 5th grade math. You guys got this. Let's do 2 examples. Now, admittedly, this is a big dog example, all right? We got negative space and positive space. We're looking for displacement, so we care about negatives and positives. All right, so we're gonna have to include those. So let's see. Just to note here, all of our boxes on the y-axis are 2. So it goes 2, 4, 6, 8, 10, 12. And our boxes, our squares on the x-axis are 1. 1, 2, 3, 4, 5. All right? So where do we start? We start at negative 12. All right? And the first thing we need to do is actually cut this up into triangles and rectangles. All right? So let's chop this up. So I'm going to draw lines between my 0, okay, and right there. So this is my first one, okay? This right here we're going to call A. This right here we're going to call B. All right? Does this make this easier if I do this? Okay? The next one we're going to make is a triangle right here. And again, pause the video, go back, see if you can do this yourself. We're going to call this one C. See if you get an answer before I do. Pause the video. Restart it. Let's see if you're right. The next one we're going to draw is a rectangle right here. We're going to call this D. And last but not least, we have a triangle right here. We're going to call this E. All right, 5 calculations. Let's do this. Again, the area of a rectangle equals base times height, and the area of a triangle equals base times height divided by 2. A is obviously a rectangle, so we're going to go A equals base times height. All right, so what is the base of this rectangle? All right, the base of this rectangle goes from 0 to 4. 4 minus 0 is positive 4. And the height goes from 0 down to negative 12, which means our height is, you guessed it, negative 12. So our base here is 4 times negative 12. 4 times negative 12 is negative 48. This is going to make for some fun math later. And this is meters, because again, it's displacement. 1 down, 4 to go. B, let's look at B. B is obviously a triangle. So we're going to use base times height divided by 2. Well, let's look at our base. Our base goes from 4 to 6. Our base is 2. And our height is the same, right? Our height is still from 0 to negative 12. So we're going to have 2 times negative 12 divided by 2. This equals negative 24 divided by 2, which equals negative 12 meters. Put boxes around this. All right. Very good. C is a triangle. C is equal to base times height divided by 2. That's my triangle, right? Triangle is just a rectangle, cut in half. So let's look at this one. All right, our base goes from 6 to 9, which is 1, 2, 3 squares. You could also go 9 minus 6 is 3. That's how I like to do it. And our height goes from 0 all the way up to 18, right? 10, 12, 14, 16, 18. So our height here, okay, from here to here, is 18. So we have 3 times 18 divided by 2. Okay? 3 times 18 equals 54 divided by 2. 54 divided by 2 is 27 meters. Again, I'm doing that in my head. Grab a calculator. Always do these separately. Do your division on top first, move everything, and then do the division. Or sorry, your multiplication on top first, and then divide. Trust me on that one. All right, up next, we got D. D moves from 9 to 13. 13 minus 9 is 4. 1, 2, 3, 4. Yep. And our height still goes from 0 up to 18. So we got a rectangle, which is just base times height. So again, our base is 4 times our height, which is 18. And 4 times 18 gives me 32. Yep, this is going to be 72. Okay? And then last but not least, I have E. E goes from 13 to 16, 17, 18. 18 minus 13 is 5. And again, 1, 2, 3, 4, 5 seconds. Our height is still from 0 up to 18. So E is equal to base times height divided by 2, right? That's obviously a triangle. My base is 5. My height is 18. It's all positive. And we're dividing that by 2. 5 times 18 equals 90 divided by 2. 90 divided by 2 equals 45 meters. Now I wanted to find the displacement, which means you got to take all of these and add them up. And this is why some are negative and some are positive. So what do we have here? We have negative 48. Okay. Okay. Maybe I do it like this. I can show you how to do it in my head. Negative 48 minus 12. Okay. Then we have positive 27 plus positive 72 plus positive 45. I like to do the positives and the negatives together. So negative 48 minus 12 gives me negative 60 plus, let me see if I can do this in my head, 27 plus 72 is 99. 99 plus 44 is going to be 144. And 144 minus 60 should give me, 84 meters? Yes, that sounds right to me. All right? That's mental math. If I screwed that up, let me know. Let me know in the comments if that looks right. Again, that's a lot of work. This is a big dog problem. I doubt you'll ever see anything like this on a test, but if you do, you are more than prepared. Let me show you a smaller example of this problem. Pause, write it down. All right. Again, I like to give you guys big examples so that when you have easier problems, you're like, oh man, this is easy. This is why you train with heavier weights than you actually use. So that when you actually use them, they're easier. Same graph, but now I want to find the displacement from 10 to 15 seconds. So we're just doing a little portion of the graph. We're only going from 10 seconds to 15 seconds. So how do we do this? Well, I only care about this area. So go to the line, draw a line down to 10, go to the line, draw a line down from 15, and we want to find the area of this shape right here, okay? Now, you're looking at this and you're like, Mr. Norris, that's not a triangle and that's not a rectangle. You're right, okay? So we need to turn it into rectangles and triangles. You want to try that on your own? Pause the video. See if you can find the area of this by yourself. Let's see if you got the right answer. Here is my first triangle or rectangle, and then I'm going to make this into a rectangle and a triangle. We're going to call these A, B, and C. Let's find A. So again, rectangles are equal to base times height. Triangles are equal to base times height divided by 2. Well, A is obviously a rectangle. So A equals my base. So let's see here. We go from 10 to 13. So this is 3. So this is equal to base times height, which is equal to 3 times my height. Well, my height goes from 10 to 18. That's a height of 8. 3 times 8 is 24 meters. Okay? All right, B is obviously a triangle. So that's equal to base times height divided by 2. My base of B goes from 13 to 15. That's 1, 2, boop, boop. Right? So my base here is 2 times my height. Well, my height goes from 10 to 18. So my height is still 18 divided by 2. 2 times 18 is 36 divided by 2. 36 divided by 2 is equal to 18 meters. Okay. And then last but not least, I have C. C is obviously another rectangle. C is equal to base times height, regular old rectangle. Okay. Our base here, well, it's 3 plus 2, which goes from 10 to 15. That's 5. That checks out. 3 plus 2 is 5. They're the same. And my height goes from 0 to 10, which is simply 10. So my base was 5 times my height, which is 10. 10 times 5 is 50 meters. All distances. In order to find my total displacement, I add them up. Positive 24 plus positive 18 plus positive 50. 24 plus 18 is 30. 42 plus 50 is equal to 92 meters. Did I do that right? That sounds right to me. Boom. So you can take any little segment of this and break it up. Whatever it is, draw the lines from the time and break it up into all of its little bits and pieces. It's actually pretty straightforward. All right, guys, this has been a review. Remember, there are videos specific to all of these that have even more examples. Watch this review. Write down the practice problems. Write down the notes. Use it for your test. All right, if you have any questions, email me. All right, good luck, guys. You're going to do great.